Hello students, in the last session we completed vectors and then we saw like trigonometric functions. So we did see like sine theta, cosine theta, tangent theta, okay, and then I asked you to memorize some of the numbers related to those thetas, right? So we saw that one. Then the final topic that we saw in the last class was like parallelogram law, okay. So we completed around like 3 topics in the last session. So in this session we will be doing like projectile motion, so that's the only thing that we are going to see. So we'll see like projectile motion on a horizontal surface, then we will see like what is the projectile motion on the inclined surface, okay. So those two are the topics that we will see in this session, okay. That too, projectile motion on a horizontal surface is something that you'll get in the examination, okay. So inclined surface is a kind of extra thing that I'm going to teach in this chapter, okay. Fine. So if needed, you can go through those topics that I'm about to teach, or else you can skip it, okay. So in the last 24-25 years you didn't get any questions from that projectile motion on an inclined plane, okay. So if you're interested, then you can go through the topics that I'm about to teach you, or else just you can leave the second part of this session, okay. So you don't get questions, right? Fine. So you can leave it if needed. In the third session we'll complete uniform circular motion, and then we'll say like kinematic equation that are related to uniform circular motion. Fine. So that will be for the next part, okay. So in this session we'll see like 2 topics, which is like projectile motion on a horizontal surface and then projectile motion on an inclined surface. In that, projectile motion on a horizontal surface is something that is in the syllabus, okay, that is needed for NEET. Inclined surface is something that's an extra that I'm going to teach you, okay. That's not needed. Even if you skip that part, it wouldn't hurt you while solving POQs, okay. Now we will see projectile motion. Fine. So projectile motion actually means, let's consider a person who is standing on the ground and then he is throwing an object, okay, at certain inclination. Fine. So in that situation, let's consider that he is throwing with a velocity v naught, okay. So in that situation you will have the velocity along the horizontal direction, same way you'll have the velocity along the vertical directions, okay. So you'll have both vertical component and the horizontal component into this velocity, okay. So obviously this is a kind of two-dimensional motion, fine, because you're having displacement along both x-axis and then the y-axis, fine. So if that was the case, then what will be the only acceleration that is acting on this object? So while throwing the ball, I just gave some initial velocity to it and then it started moving upwards, fine. So the only acceleration acting on that object in the motion will be like acceleration due to gravity, okay. So that acceleration due to gravity will obviously be acting downwards, fine. So you don't have any other acceleration coming into this picture. Let's consider the earth's surface to be like flat. So in that situation, let's see how does the velocity along the x changes and then how does the velocity along the y changes, okay. So that's what we are supposed to find here for a projectile motion, fine. So the thing that we will find is like the displacement, what will be the equation for the displacement along the x, and then we will find like what is the displacement along the y, okay. So how does it relate with the time? That's what we are supposed to find. Then we will see like what is the maximum height reached and then what will be the range of this particular projectile, okay. So we'll see, those are the things that we will see in this projectile motion, fine. So we'll get around like 3-4 formulas that you need to memorize, okay. So those end results has to be memorized. That is when while solving the PAQ it becomes easy for you to do it, okay, fine. So here the guy has thrown an object with certain velocity v naught, that too with an inclination theta, okay. So only when you have that inclination you will have projectile motion into it, right? If it was like only upwards, if the theta was like equal to 90 degree, in that situation that is like in one-dimensional motion, fine. So that is something that we have seen in the previous chapter, which is like kinematic equation, okay. So here it is at certain inclination theta, therefore you will have displacement along both those directions, fine. So here in this situation I'll split this component into 2 parts, which is like velocity along the x and then the velocity along the y, okay. So velocity along the x will be like v naught cosine theta, because this is closer to theta, okay. This is something that I've told you in the previous session. So you'll have v naught cosine theta along the x-axis. Same way, velocity along the y will be equal to v naught sine theta, okay. So now you have got both those component, vx and then the vy, okay. Let's see what will happen to the vy and then the vx, okay. In the entire motion, as I have already told you, only acceleration that is acting on this object is like acceleration due to gravity, okay. So it is acting exactly downwards, fine. So here velocity along the y will keep on changing, okay, will keep on decreasing during its ascent, okay, and then when it reaches its maximum height, when it reaches its topmost point, in that situation velocity along the way becomes zero, right? Obvious. But what will happen to the velocity along the x? So velocity along the x is not going to change because there is no any opposite acceleration for the x direction, right? So you will have like air drag force and all those things into it, but let's not consider, let's idealize the entire situation. You don't have air, anything, something like that, fine. So in this simplistic situation, only acceleration that is acting on this object is like the acceleration due to gravity. Let's neglect all those other parameters, okay, fine. So in this situation, then obviously velocity along the x is not going to change, it is always constant, okay. So at every instant of its motion, velocity along the x is constant because in that x-axis you don't have any acceleration acting on that object, okay. So you'll have vx, which is like v naught cosine theta at every instant, but that's not the case with vy, right? It will change at every instant. When it reaches its topmost point, velocity along the y becomes zero, but where in the case of velocity along the x, it is still the same thing, which is like v naught cosine theta, okay. So this is something that you need to know. Then what will happen to the velocity along the way? After reaching its maximum height, the velocity along the way becomes zero. Then what will happen is the direction flips, right? Therefore, during the second part of its motion, you will have the flipped velocity, which means velocity will be downwards at rest all other instant, okay. So when it is about to reach the ground, so you'll have the same velocity, okay, because like you should have known from your lower grades, energy will be like always balanced, right? So we'll do that energy balance stuff in the work, energy and power. As if now what you need to know is whatever velocity that I'm given to the ball, okay, it's the energy for that particular ball, okay. So when it is going to return back to its original position, which means to its ground state, what should happen? You should end up getting the same velocity because energy is neither lost and nor gained, okay. Therefore that is like energy conservation, obviously, right? So we'll end up having the same velocity, which means same magnitude of velocity, but the thing is the direction of velocity will get flipped only along the y direction because that's the only direction where you have the acceleration acting, okay. So it doesn't collide with any other object, therefore energy is conserved, which means whatever magnitude that I thrown it, you will get the same magnitude when it reaches the bottom of the earth, okay. So when it hits the earth, you will have velocity along the y to be like velocity along the y to be like minus vy, okay, which is nothing but v naught cosine theta in that situation. Same v naught sine theta. Same way velocity along the x will be the same thing, which is like v naught cosine theta, okay. So negative vy will be there when it reaches the bottom of the earth, okay. So bottom of the earth surface, fine. So these are something that you need to know regarding the projectile, okay. So then what we'll end up finding is the range and then the maximum height, right? So the range here is this one. So the path that it has covered along the x-axis in the earth surface, okay, or the point where which I have thrown it, okay. So that will be considered as range, okay. So here the range is like this distance, which means from the point of throw and then the point where it hits the ground back. Then the maximum height will be like when the velocity y goes to 0, you will end up getting the maximum height. Therefore, the maximum height here is this point, fine. So this will be my maximum height, fine. So this is the maximum height. I'll call the maximum height as capital H, fine. So now let's deduce some relations with respect to this projectile motion, okay. First I will find the relation between velocity along the x and then the displacement along the x, okay. So obviously we know velocity along the x is not going to change, therefore this is like a straight thing, okay. So velocity along the x will be equal to displacement covered along the x-axis divided by the time, okay. So straight away, so x divided by t, fine. So instead of vx, I'll be able to substitute v naught cosine theta, right? So you'll have v naught cosine theta, which is equal to x divided by t, fine. So if I need to get a relation between x and then the v naught cosine theta, what I should do, I'll have to just do the cross multiplication, fine. So x will be equal to v naught cosine theta into t, okay. So now I have got the relation between x and then the time, okay. So if I just substitute the time, required time, I'll end up getting the required x position of that projectile, okay. So if I substitute like 1 second, I'll be able to get what will be the x distance that this projectile has covered, okay. If I substitute like 2 seconds, then I'll end up getting what is the x distance that it has covered. Okay, so this is something that you need to know. So now I have found the relation between x and then the time t, okay, using the constant velocity along the x-axis. Fine. So next what I need to find is I'll have to get the relation between y and then the time, okay, displacement along the y and then the time. In this situation, if I see y is velocity along the y is not constant, okay, but the thing is it is undergoing constant accelerated motion. Fine, which means like I'll be able to put in kinematic equation because acceleration due to gravity is constant. Fine, therefore I'll end up substituting kinematic equation, which is like s, which is equal to ut plus half ad square. Okay, so that's the equation that I'm about to substitute here. So I'll have s, which is equal to ut plus half at square. Okay, so now I have put in the kinematic equation. I'll substitute the respective y, and then for u I'll be able to substitute the initial velocity, which is like v naught sine theta. Time will be the same t. Half, instead of a I'll substitute like negative g, and then you'll end up getting t square. Okay, so if I put all those things into the equation, you will have y, which is equal to v naught sine theta into t. Okay, so minus half g t square. So this is what you'll end up getting. So this will be the relation between y and then the t. Okay, so x and t is something that you get it directly because velocity along the x is constant. In this situation, I have just used the basic kinematic equation. Okay, s equals ut plus half at square. Fine. So next what I do is I need to get the velocity along the y. Velocity along the x is constant, but velocity along the y, I know it just keeps on changing. Fine, as it moves upwards, the velocity keep on decreasing. As it moves downward, the velocity increases in the negative direction, right? So if you need to get the velocity along the y for that particular time, what I need to do? So here I have got the equation for the y, right? If I differentiate it one time, I'll end up getting the velocity along the y, right? Straight away, simple. Fine, so I'll just differentiate it and then I'll get the velocity along the y. Okay, so here velocity along the y will be equal to, if I just do the differentiation with respect to time, t is to the power 1, therefore you'll have like constant thing, which is v naught sine theta, and then if I differentiate the second term, you'll have like t square, which will be nothing but 2t, right? So you'll have like minus gt. Fine, so 2 it will get cancelled, and then you'll just end up getting minus gt. Fine, so this will be the velocity along the y. Now we have got the relation between x and t. Fine, and then y and t. Okay, and then we also found what is the velocity along the x and then the velocity along the y, right? So only thing that is missing over here is the relation between x and then the y. Okay, so to get the relation between x and y, what I'm about to do is I'll just rearrange the above equation with respect to t. Okay, so t equals x divided by v naught cosine theta. Okay, so that is how we'll get. Now what I do is I just substitute this t in this t. Fine, because both those time are just the same thing. Now I'll be able to relate between x and then the y. Fine, so you should get this one. We will do that one in the next page, right? If I substitute t equals x divided by v naught cosine theta in the y equation, I'll have y, which is equal to, fine, so I'll just do the substituting stuff. Y, which is equal to v naught sine theta. Fine, so that's what you'll have, and then you'll have like t. Okay, so instead of t, I'll substitute x divided by v naught cosine theta. Okay, so here then you'll have minus half gt square, right? So I'll have like half g, so instead of t square, I'll substitute x divided by v naught cosine theta the whole square. Okay, so this is what you will have here. I'll be able to cancel out v naught, v naught. Okay, so rest all the things will be there as such. So we will have the final equation will be like v naught. So v naught will get cancelled out, therefore you'll have like x tangent theta. So the first term will be x tangent theta minus half g, okay, x square divided by v naught square and then cosine square theta. Fine, so this is one of the equation that you need to remember. Okay, so you got like equation between x and t, that was straight away. Then you got like equation relation between y and then the t. Then now you have got the relation between x and then y. Okay, so this is one of the equations that you need to memorize. So here, what does this negative sign signifies actually is this represents that the parabola is open downwards. Fine, so obviously if you consider this equation. So left hand side equation is like y with respect to y. Therefore, this parabola will be along the y-axis, fine. And then you got like x component, fine. So it is quadratic equation. Then obviously this should be a parabolic equation, right? So from your basic math class, you should know this one. So that too, you have a negative sign in front, which means this is obviously a parabola which is like open downwards, fine. So we have seen something related to this one in the differentiation thing, okay? From in the motion in a straight line, we did see those things, fine. So if it was like negative, then it actually means the parabola is open downwards. So that's what this represents, fine. So you should be clear with all those equations that we have learned, and then you should know it by heart, okay? Right, so that is when it will be easy for us to do the solving stuff. Next, we need to find time taken to reach maximum height, fine. So the hint here is velocity along the y will be 0 when it has reached the topmost point, fine. So with that thing, I'll substitute like Vy equal to 0. I know the velocity along the y equation, fine. So if I do the rearrangement thing, I'll end up getting the time, fine. So that will be the time taken to reach maximum height, fine. Got it. So now I'll just put the velocity along the y equation. So I'll have like Vy, which is equal to V naught sine theta, got it, minus gt, right? So here, obviously, velocity along the y at the topmost point is going to be like 0. Therefore, velocity along the y is like 0, right? So just do the rearrangement thing. You'll have gt, which is equal to V naught sine theta, right? So the time t which is needed to reach the maximum height will be like V naught sine theta divided by g, right? So t is equal to V naught sine theta divided by g, right? It is good to remember this formula, so you should memorize this one, right? I hardly tell you some formulas to memorize. It is better to memorize those things, fine, so that in the examination you'll end up saving time, fine. So if you know the formula straight away, we will be able to do the solving quick, that's why. So here, so the time taken to reach the maximum height is like t, which is equal to V naught sine theta divided by g, fine. So when you look at the path, it seems to be clear that the first part is symmetrical to that of the second part, okay? So whatever happened in the upward direction, so same thing will happen in the downward direction. So this is like a symmetrical thing. Parabola is obviously a symmetrical stuff. Therefore, the time taken to reach the maximum height will be the same as the time taken by that object to reach the ground, fine. So what will be the total time of flight or the total time taken for that complete projectile? It will be equal to 2 times the V naught sine theta divided by g, right? Therefore, time of flight or the total time taken will be like equal to 2 V naught sine theta divided by g, fine. So this is just a simple logical understanding, right? So you'll have like 2 V naught sine theta divided by g. Got it? So now I have got the time taken to reach the maximum height, right? Next, I'll have to find maximum height, right? So to get the maximum height, the equation that I need to choose is like displacement equation, okay? So that thing, y equals V naught sine theta t minus half gt square, right? So that's the equation I'm going to choose here. So instead of y, I'll substitute the maximum height, okay? So that is like capital H, fine. So for time, I'll substitute the time taken to reach the maximum height, right? So if I do those things, if I put all those things together, I'll end up getting the maximum height. So let's do the solving. You'll get the answer straight away. Here you got like H, which is equal to V naught sine theta into t, fine. So instead of this t, I'll substitute V naught sine theta, okay, divided by g, okay. So you got like 2 V naught sine theta, V naught square sine square theta, then you have minus half g, and then you got like t square, right? So instead of t square, I'll substitute V naught square sine square theta divided by g square, okay. So here if I see, I'll be able to cancel out g's, so you'll have like 1g it got cancelled out, right? So then what are all things that you have got here? So you got like v naught square sine square theta, you got the same thing, right? V naught square sine square theta, then you got like g in the denominator, fine. So all those terms are same except this numbers, okay. So here it is like 1, here it is like negative half, okay. So if I just factor out all those things that is common, you will have something like this. You will have v naught square sine square theta divided by g, and then you will be left with 1 minus half, okay. So that's the only thing that will be left inside the bracket. So the maximum height will be equal to half, okay. So in this bracket you just have half, and then you'll have like half v naught squared sine square theta divided by g, okay. So the maximum height here is V naught square sine square theta divided by 2g. So that's what you got over here. Okay. So with respect to the time, you had like V naught sine theta divided by g. So in this situation, you have like V naught square sine square theta divided by 2g. Okay. So next, the thing that we are going to find is like the range. Okay. So range is the maximum horizontal displacement that it has covered. Okay. So x equation is straight away. So x will be equal to V naught cosine theta into t. So instead of this t, I'll substitute the total time of flight. Okay. So the total time taken is something that I'll substitute over here. And then if I do like a simple trigonometric relation, you'll end up getting the range. Okay. So if I solve this one, you'll have like x, which is equal to V naught cosine theta. So instead of t, I'll substitute 2 V naught sine theta divided by g. Okay. So the total time taken is something that I've substituted over here. So the relation here is actually sine 2a, okay, which is nothing but 2 sine a cosine a. So this is the relation that I'm going to use here. So the sine and cosine components here is like cosine theta. This is the first one, and then you got like 2, and then you got like the sine theta. Okay. So instead of 2 sine a cosine a, I'll be able to substitute sine 2a. Okay. So this is one of the trigonometric relations. Fine. So you need to know both those steps. Okay. So in some of the questions, I'll need this formula, the above one, or else I'll need like sine 2a, that one also. Okay. So it is better to know this formula and the next one also. Okay. So it is better to know the entire step. That's what I'm telling you. Fine. So the range here is, so the range here actually is V naught square. Fine. So instead of 2 sine a cosine a, I'll substitute sine 2 theta. Okay. So this is not square. This is actually sine 2 theta. Fine. So in this situation, it was like sine square theta. Here it is like sine 2 theta divided by g. Fine. So this is the formula for range that you need to know. Fine. So with respect to projectile motion on a horizontal surface, you'll have to know the relation between xt, yt, okay, and then you'll have to know the relation between that x and y. Okay, so that lengthy big one. Fine, you'll have to know that relation. Then you should know the time of flight, which means the entire time taken. So half of that will be like time taken to reach the maximum height. Then you'll have to know the maximum height, what was the displacement. Okay, and then finally you'll have to know the range. Okay, so these are the formulas that you will have to memorize it, right? So only thing is, if it is in your memory straight away, you will be able to solve it quick. Or else if you need to do any like 2-3 extra steps to get that formula, it will consume time during the examination. Okay, so therefore it is better to memorize these formulas. Right. So next we will see projectile on an inclined plane. As I've already told you, this is not necessary for the NEET. Fine, because you don't get question from this part. This is a kind of extra part that I'm going to teach. If you are interested, you can listen through the next part of this lecture. Fine. If not, you can skip it. Fine. So this thing isn't going to hurt you. The third session where we will do like uniform circular motion and those stuffs. Okay. So let's move on to projectile on an inclined plane. Projectile on an inclined plane. So here you got a plane which is at certain inclination to that of the ground. Okay, so in the previous case we considered the ground to be like x-axis, but in this situation I'll consider the x-axis to be at certain inclination with respect to the ground. Okay, so this is with respect to the ground flat surface, and this will be my vertical thing. Therefore acceleration due to gravity will obviously act downwards, right? But with respect to this x and y coordinate that I've introduced as new thing, okay, with respect to the inclined plane, you will have this g component split into two stuff. Okay, we'll do that splitting as if now this g is actually acting downwards with respect to the earth, but with respect to the surface that I've considered, it is at certain inclination, obviously, right? So with respect to this horizontal surface, which means along the x, you got like y, that will be my y, it's right? So here, as usual, I'm going to throw an object with certain inclination. I'll consider that inclination to be like alpha. Okay. So in this case, I'll introduce like two angles. Therefore, the first angle I consider here is like alpha. Okay. So in the previous situation, I consider it to be like theta, but in this situation, I'll consider it to be like alpha. Okay. So the other one angle is like the angle between the inclined plane and then the earth surface. Okay. So that angle is actually considered as beta. Okay. So you got like two angles. One is like alpha and the other one is like beta. Okay, so this angle will be like beta. Fine. So the angle of throw with respect to that inclined plane will be like alpha minus beta. Okay, so this angle here over here is actually alpha minus beta. Fine. So these are the angles that you need to know. So the angle of throw with respect to the ground is actually alpha. Then the angle between the inclined plane and the ground is like beta. Then the throw with respect to the inclined plane that I've chosen will be like alpha minus beta. Fine. So you got like two angles, and then alpha minus beta gives you the third angle. Fine. So here the velocity along the y will be at certain inclination with respect to the vertical stuff with respect to the ground. Okay, so these are the things that you need to know regarding this projectile thing. Fine. So what are the things that I need to consider here is the acceleration along the y. Okay, so the acceleration along the way, which means I'll just split this g component into two components. That will give me the acceleration along the y and then the acceleration along the x. Okay, so here in this situation you got like both those acceleration along the x is also possible, and then acceleration along the y is also possible, because I considered the x to be at certain inclination with respect to the ground. So ground is not the x in this situation. Fine. So now I need to split this g into two parts. Fine. So the pattern in which I'm going to split this one will be like these two will be my resolving stuff. I will resolve it in such a fashion that one component is going to be like perpendicular to the x and the other one is like parallel to the x. Okay, fine. Let us consider two lines. Okay, the angle between them, let us consider it to be like beta. Okay, fine. So I'll be able to match it straight away. So the angle between them is like beta. Fine. So what I'm about to do here is I'm just going to cut it such a way that one of the line is actually perpendicular to the line here. So one will be like perpendicular to one of the lines. Okay. And the other line will be perpendicular to the next line. Okay. So here, so in the situation, how I drew this, the second angle is such that it cuts both those lines perpendicular to each other. Okay, so in that fashion I have drawn the second angle. So in this situation it is the angle between this one and the angle over here is just the same thing. Okay, so these two are like beta. Fine. So it is something like this. I've just rotated it by an angle of 90 degree. I've just flipped it a little bit and then I got the next angle. Okay, so obviously these two angles have to be same. Right. Okay, so that is how I'm going to match in the situation. So you got like one line, okay, that is piercing this x perpendicularly. Got it? And then you got like another one g which is piercing this ground perpendicularly. Okay, so the angle here is like beta, right? Obviously, then if I'm going to do like perpendicular cut in the situation, this one will be like perpendicular and this one will be like perpendicular. So obviously the angle between the inclined plane and the ground is beta, therefore this angle should also be beta. Okay, so the angle over here is actually beta, right? So now I have got this angle which is like beta. Then I'll just put, okay, so the component that is close to beta will be like cosine component, therefore you will have g cosine beta here. So this component is actually g cosine beta. Now I have got the acceleration along the y. Okay, so this is actually acting downwards, therefore it should be like negative g cosine beta, right? So the acceleration along y is nothing but negative g cosine beta. So the first thing is done. Then what should be the acceleration along the x? Fine. So this is the acceleration along the x. Okay, obviously the x is positive in this direction towards the right side, therefore this is acting in the towards the left side, therefore this should be negative, right? So acceleration along x will be equal to negative g, it should be like sine beta. Okay, so now I have got acceleration along the x and then the y. Fine. So the next thing that I need to know is what will be the initial velocity along the x and then the y. That's what I need to know, right? So the initial velocity along the x will be like ux and then the uy. So here, so this will be like my u. So in the previous situation I considered it to be like u naught, but in this case I just took it as u. Fine. So these are some notation that I'm sticking to. Just get used to this one. Okay, fine. So let me consider the initial velocity to be like u, therefore ux, initial velocity along the x will be like ux, that's going to be like cosine, okay, alpha minus beta, right? So ux will be equal to u cosine. So the same logic that we have seen with the projectile, same thing, right? So u cosine, you'll have like alpha minus beta. So that's the initial velocity ux. Next you'll have like initial velocity along the uy, which is nothing but u cosine, no, sine, right? So the perpendicular component will be like sine, therefore you'll have like sine alpha minus beta. Fine. So now I have found like ax, ay, and then I got like initial velocities, which is like ux and then the uy, right? So the thing that I need to find with respect to the inclined plane is like maximum height, then I'll find the range, and then I'll get the time of flight. So to get the time of flight, obviously in this situation, it started from 0 along the y-axis. Same way, when it has completed its motion, it ended up getting y to be 0, right? So in this situation, it seems to be clear that y, the position will be like 0, or else the displacement will be 0 at the end of the time, right? When time t will be equal to 0, the position will be like 0. That will be my start. Same way, after the motion has completed, again you will end up getting y to be 0 when it has completed the entire motion, right? Entire projectile motion, fine. So here I'll be able to substitute y to be 0, which means displacement along the y should be equal to 0. Therefore, in that situation, I'll be able to substitute s equals ut plus half at square, okay? So instead of y, I'll substitute it 0. That's what I have written over here. When the projectile lands, y coordinate is 0, okay? So here y will be equal to 0, and then you got like ut plus half at square, right? So instead of u, I'll substitute like initial velocity along the y, which is nothing but 0, which is equal to u sine, okay, alpha minus beta. So time t is something that I need to find, which is nothing but the time of flight, okay? So u sine alpha minus beta, and then you got like t minus half, okay, at square, right? So I've just substituted the minus straight away. So instead of a, I'll substitute like ay, acceleration along the y-axis, right? So acceleration along the y-axis is like g cosine beta, and then you got like t square, right? So what I need to find here is the t. Okay, if I do the solving stuff, which we'll do it on the next page, I'll end up getting the time. So the time t here is actually the time of flight, right? So now I have found the first thing, which is like time of flight, right? I have just rearranged the previous equation and I've written over here, okay? So it will be like half g cosine beta t square, which is equal to u sine alpha minus beta t, okay? So let me cancel out the t. I'll end up getting the time of flight. So t, 1t will get cancelled out, and then I'll just be left with only 1t, which is nothing but the time of flight, capital T, right? If I just rearrange the above equation, I'll end up getting the time of flight, which will be like 2u sine alpha minus beta, and then in the denominator you'll have g cosine beta, okay? So you'll have like g cosine beta, right? So this will be the time of flight for an projectile with respect to the inclined plane, fine. So next what I need to find is the range and the maximum height, right? So those two are the things that is needed. So the range here is, I have drawn the previous diagram once again. So the range here is actually the point where it hits the ground with respect to the origin, okay? And then the two is related to that of the inclined plane, so this will be my range, fine. So the maximum height here will be like this one, which is like the maximum height. Even in this situation, when it has reached the maximum height, obviously velocity along the way goes to 0, right? So that will be the maximum peak with which it could actually reach, okay, right? So to get this range, what I'll find is I'll just consider this entire projectile to be the normal one with respect to the ground, and then I'll end up getting the x dash, okay, which means I'll end up getting this distance, fine. So if I end up getting this x dash, I obviously know the beta here, right? So I need to relate between the range and then the x dash with respect to the beta, right? So cosine beta will get me the range, fine. So let me do it. So once I solve it, you'll be able to understand this one. This is actually an easy thing, right? So here to get the range, what I need to do is I just need to know the time of flight with respect to the inclined plane, okay? So to get that one, first let me consider this x dash, okay, and then I'll have to generate an equation for it. So this x, to get this x dash, I'll just consider this projectile to be the normal one with respect to the horizontal one itself, right? So for that equation, x dash is obviously equal to u cosine alpha into t. Obviously with respect to the ground, the velocity is not going to change, right? So here this is something that we have already seen, right? So here I'll use that one, x dash, which is equal to u. In the previous situation, I used theta because that was the angle of throw, but here in the angle of throw with respect to the ground was actually alpha. Therefore, I'll use that one, which is like u cosine alpha into time t, right? So here it doesn't reach the earth surface, instead it has reached an inclined plane, okay? So I'll have to substitute that time. So what will be that time? So that will be the time of flight for that inclined plane, right? So now I have already found the time of flight for the inclined plane, therefore I'll substitute that time here. Okay, so the x dash is something that I'll get straight away. If I just substitute that time of flight, I'll get it, right? So the time of flight will obviously be equal to 2u sine alpha minus beta divided by g cosine beta. Fine. So now I have got the x dash. What I need to find here is actually the range. Fine. So here cosine beta will be equal to range. I mean cosine beta will be equal to cosine beta will be equal to x dash, which will be my adjacent, divided by r, right? So I need to get the r, therefore it will be like r, which is equal to x dash divided by cosine beta, right? So x dash is something that I found it already, so I just have to divide this entire term by cosine beta, right? If I just divide it by cosine beta, I'll end up getting the range over here. Okay, so range r will be equal to x dash divided by cosine beta, right? So you have x dash divided by cosine beta. So with this complete term, I'll just divide x divided by extra one cosine beta, I'll end up getting the range. Okay, so you'll have, so the final answer will be like u cosine alpha into 2u sine alpha minus beta divided by g cosine square beta. Okay, so you'll have like g cosine square beta. So that's it. So this is the range that it has covered with respect to the inclined plane. So the next thing that we need to find is the maximum height. Okay, so to get the maximum height, I'll use the same logic, velocity along the y. So when it has reached the topmost point, velocity of the y will be 0. Okay, so that is when with respect to this plane, it would have reached the maximum height, right? So if you don't have any other velocity along the y, then obviously it will not be able to rise more than that. So that point should be the highest point with respect to that of the inclined plane, right? I just need to find the maximum point here. So to get the maximum height, the kinematic equation that I'm going to use here is the third kinematic equation. Okay, so which is like v square minus u square, which is equal to 2as, because we need to find the maximum height. Okay, so in the third kinematic equation, I'll be able to relate with respect to velocity and then the time and then the displacement. Okay, so that displacement will be like maximum height in that situation. Fine. So the third kinematic equation is something that I'm going to use. So you will have vy square, right? Obviously this is going to be 0 because at the maximum height, velocity along the y, final velocity will be like 0 minus uy square, right? The formula that I'm using here is like third kinematic equation, which is equal to 2as, right? So instead of a, I'll substitute the acceleration along the y, and then you'll have like h. So that will be my maximum height, right? So in this case, I'll just put this one to 0 because at the maximum height, velocity was equal to 0. And then what should be the initial velocity? Initial velocity will be equal to u sine alpha minus beta, right? I'll substitute that one. So you will have u sine alpha minus beta the square, right? So u square sine alpha minus beta the whole square, which is equal to 2, instead of ay, I'll substitute like minus g cosine beta, right? So that was along the y-axis, therefore you will have minus g cosine beta, and then you have like h. Okay, here I just left one negative sign, which is like minus uy, right? Minus uy the whole square. Fine. So in this case, I'll just cancel out those two minus, so it becomes positive. So height h will be will just be the rearrangement of this stuff, right? So height h will be equal to u square sine square alpha minus beta divided by 2g cosine beta. So that will be my answer, which is like h max. Fine. So h max here is u square sine square alpha minus beta, and then in the denominator you have like 2g cosine beta, right? So in the denominator you had like 2g cosine beta. Fine. So now we have got the maximum height and then the time of flight, then we have got the range. Fine. So as I've already told you, do not want to memorize these formulas because you don't get questions from this one, but the thing is you'll have to memorize more projectile on a horizontal surface. Okay, so that is something that needs to be memorized. So this is something like an extra thing that I've taught you. Okay, if you just wanted to know those understanding, just go through this thing, that's enough, right? So in this session we saw projectile motion on a horizontal surface, same way we did see projectile motion on an inclined plane. Okay, so with this the video gets completed. Bye.